Hello. In this lecture, we will be studying the four main pillars of the object-oriented programming. So, first pillar we will be studying is inheritance. So, today we'll be mastering inheritance, super method, and overriding in Python. And just a disclaimer: all of these PPTs are made using Notebook LM. I'll just show you the trademark just for copyright purposes. I'll just put it here. Now you can see the trademark. I don't want any copyright issues, so I'm just mentioning that all of the videos made in these lectures are made using Notebook LM, these PPTs. You can make them yourself too. And so we'll be starting with inheritance. What is inheritance? Inheritance is a fundamental concept in OOPS that allows a class to inherit attributes and method from another class. So there is a base class that is called parent class, and there is a derived called which is also called child class. So the base class is the blueprint that contains generalized attributes and behavior, and the derived class has evolution of their traits, including the traits in the parent class. Just as a biological dog inherits trait from an animal, a Python dog class inherits method from an animal class. So why use inheritance? First of all, structural use models real world hierarchies like animal to dog, then person to employee, then employee to something else. Then reusability promotes code and your code reusability by sharing common attributes and method across multiple classes. So you don't have to actually make a class. Suppose if you don't make a class, you don't have to make every single person, you don't have to make the same attributes. Now maintenance, it simplifies maintenance through centralized updates, fix a bug, parent, and it's instantly fixed in all childrens. So that's maintenance. Customization, if you want to customize anything, you can easily customize. Scalability, because it's pretty scalable code and extensible software design by utilizing polymorphism. Dimensions. So the origin of the base class is generalized blueprint and derived class is specialized offshoot. So basically this derived class has been derived from the parent class, like all the properties of the parent class is in the derived class plus its uh, proper properties of the child class. And capabilities, it limited to its own defined attributes and methods, possesses its own attributes plus methods plus everything from the parent class. Codependency, base class is independent and run perfectly without any derived class, but the derived class is dependent and cannot work without a parent class. Any because will just remain incomplete and inconsistent. Now, upward access has no parent to call, can explicitly communicate with the parent via the super function. Right. Now, the lineage in action. Now, the animal class as info print I am an animal. Now we have another class called dog, but it's inheriting every property in the animal class. So you can also call the info function from the dog class. So you can say sound bark. Now you created an object D, and you can say dog.info, it will also print info, and d.sound, it will also print the sound. So this is called inheritance. Every attribute in the animal class can also be accessed using the dog class. Method resolution reorder, MRO elevator. So first of all, there is child calls. There, there is a method called super. The elevator travels up the method resolution order to the parent. Then it takes the action and then it goes down. So what is the use of the super function? Sometimes it's asked in MCQs. The super function calls methods from a superclass following MRO. It is commonly used to let the parent class handle the initialization of shared attributes. So the super function calls the method from a superclass or the parent class, and it uses the MRO ladder. First of all, it will go to the parent, and then constructor execute the setting and the name of the attribute. Then the initialized attribute is brought back down and attached to the child instance. For example, here you have an animal class, an initialized name, then you have a dog class, animal is inherited. Then you also create a constructor here, and you are inheriting. So this name can also be now used in this entire class, the dog class. So super dot init. So you are initializing the name of this animal class into the this into the animal dog class. All right. So intercepting the request, method overriding. So what is method overriding? Suppose there is a method d dot sound. Does dog have its own sound to own sounded method? If it has its own sound method, it's overridden. Signal is intercepted locally, parent's version is entirely ignored. So that means if there is a function called sound in a parent class and a sound in the child class, then sound this parent class sound will be overridden by this child class sound. This will be overridden. Overriding allows the child class to provide its own localized implementation of methods that already exist in the parent class, customizing the behavior while maintaining the inheritance link. Right. So the class animal flipping the switch code. So there is a class animal and the sound attribute. Then we have to print some generic sound. Now dog will bark. So here, if you do d dot sound, it will say bark, not not some generic sound, because you have overridden this function. And there is something called method overloading. Method overloading is not supported in Python. This you should remember. Sometime it's asked in the questions. Synthesis, the anatomy of a subclass. So this is I have already told you. Now knowledge check concepts. Now let's do some question answers. Inheritance in OOP allows the class to combine multiple classes into one. Define multiple methods with the same name. Inherit properties and behavior from a superclass. This is correct. Why is this not correct? This is basically encapsulation. This is abstraction. This is polymorphism. All right. Which function is commonly used in a child class to call constructor of the parent class? Superclass, obviously. There is no method name parent, base, or inherit. What will the output of the following code? So, vehicle class, uh, there is a vehicle class and it's saying c dot print details. So, car is an object, so it will car run fast. All right. So, this is all for inheritance. Now, we'll be doing next thing, that's encapsulation. And before or yes, we'll be doing encapsulation, and after doing all the four pillars, we'll be moving ahead with the questions of not questions, we'll just do implementation of all the four pillars into the code editor, and that will be all for object oriented programming, because there are no specific type of questions that can be asked. uh, like it will only use for loops and stuff, and the basic knowledge of OOPS concept. If you know basic knowledge of OOPS concept, you can easily go ahead and solve all the questions. So as we are just covering Python basics, so we'll be just moving ahead with whatever we are doing. So now the next topic is uh, yes, there is some error and there is a PPT for encapsulation. Yes, this is a PPT for encapsulation. Now, architecturing the digital vault. So take encapsulation as vaulting. So you are just wrapping up. So in interviews, there is a basic definition for encapsulation. You can always use it. Wrapping up of methods, data, and classes. It's called encapsulation. That's it. Or you can also say binding of data and behavior into a single unit is called encapsulation. So that's encapsulation. So the protective barrier for data integrity. So I'll just explain it here. So this is behavior. You can say methods. The def ones are called methods. This is the class, and these are variables. And you are wrapping all of it in one, and this is called encapsulation. So what is the usability? It eliminates the needs to explicitly pass data around. The object carries its own state. Abstraction, it hides complex internal implementation, discloses only necessary functionalities, and independence, it allows future internal changes without breaking external codes. Now, unauthorized access is protected, and accidental modification is also protected because it's stored inside a vault now. Here are the advantages for encapsulation. First of all, data protection prevents chaotic external overrides of critical states. So, and control updates forces data modification to pass through strict validation gates. Modularity centralizes data handling logic, makes large code bases vastly easier to maintain. So if you are just encapsulating most of the similar kind of data into one vault, it will be obviously modular and easy to manage. Data protection will also be easier, and updates will also be easier. Now, there are three tiers of access control. This is called access modifiers or access specifiers. Yeah, access specifiers. So the first of all, there are public members, then there are protected members, then there are private members. So public members mean that the entirety of the class is visible to everyone, and everyone can change everything. So open to everyone. You can say open source. You go into an event, you do everything there. That's the ID card for you. Then protected members, let's say the employee badge, only a few members, specified members can access it. And then private members, strictly restricted to exact core class, only that exact class can control the uh, members inside of it, or say methods inside of it. So first one is for layer 1, public member default to open access. This is the code. So just basic code that I have taught you in the previous lecture is open public code. So like this, door is open for everyone. Just like my lectures, everyone is open to learn. And employee class, we have to initialize and just display name. This is basic oops code, class code. Now let's say protected members. So you write self dot a underscore age. Okay, so that means protected class. Only accessed within subclass. Like this is inherited, so this is subclass. So the single underscore, a gentleman's agreement. It flags a variable as intended for internal or subclass use, though Python does not strictly block outside access. Right. Now private members lock down direct access double underscore. So double underscore triggers a structural lockdown, resulting in an immediate uh, attribute error if accessed internally. So you cannot directly access the salary because it's not allowed, because it's in private attribute. The mechanical truth, name mangling. So key concepts: unlike C++ or Java, Python does not enforce strict privacy at the compiler level. Instead, it utilizes name mangling. The interpreter renames any variable with a double prefix, and it operates a strong deterrent against accidental access rather than a impenetrable cryptographic wall. So it does not just create a wall that you can't access, just like C++ or Java. It just says that there is a gear that will manage using the Python interpreter and uses name mangling. Encapsulating behavior, private and protected methods. So public gateway, protected machinery, and private machinery. So you have a button, and protected machinery is seen by mechanics, you can say, and these gears cannot be seen by anyone. These are inside the vaults and only be seen by the engineer who created it itself, right? Now you can say that show balance is protected, single underscore. Now update balance is private because you cannot update balance. You can see updated balance and show balance. So just passed all of this into the public class. Now this is accessible to everyone. Now public class is accessible inside the class. These are the chart, and there is no underscore, single underscore in protected, double underscore in private. uh, Public class is accessible inside class, yes. Protected is also accessible, private is also accessible. Subclass protected and private are accessible, where private is not accessible. Accessible outside, yes, but discouraged in protected, and obviously private, no. The save gateway, getters and setters. So this is just to understand the code, getters and setters. So first of all, you create a class employee that then you initialize a salary with double underscore, that is protected class, private class, and then you just define salary as get salary. So you are getting the salary, and then set salary. Set salary means that you are setting the salary amount. So if you want to get salary, get underscore salary is the method used. A Python trust model. Uh, First of all, their first layer is public domain, then getter setter checkpoints and validation, then name mangling mechanism, then private data. So this is all for encapsulation, I guess. Now, now we have to go through what abstraction, I guess. So this is abstraction PPT. We can first do inheritance is done, encapsulation is done. We can do polymorphism first. So polymorphism means has two words, poly and morph means different or many forms. So one method showing many forms, many behavior forms, this is called polymorphism in Python. So from strict identity to dynamic behavior, suppose here we have process payment method. So Process payment can process payment from the credit card, uh, or either UPI payment or wallet payment, net bank payment. So one process payment method is doing many tasks under same name. So this is called Python's polymorphism. So the system calls a single uniform method name. The underlying execution dynamically changes based on the data type it interacts with, enabling highly scalable code. So Pythonic polymorphism taxonomy. So the polymorphism means many forms. So compile time in static is method and operator overloading resolved before execution. So the domain of Java and C++, Python does not support true compile time resolution because it uses interpreter. Now runtime is dynamic method overriding. Now behavior decided mid execution based on calling object Python's native territory. So it's mimicking static overload at runtime. So suppose sometimes you want to add two variables and sometimes we want to add three variables. This is pretty possible by using star args. This is argument with multiple parameters. Now, unlike Java, uh, Python cannot survive multiple variation of function at same compile time. Instead, a single function acts as a dynamic funnel, handling different argument structures on the fly during execution. So in Java, what it happens is Python cannot define multiple variation. Sorry, Python cannot define multiple variation of a single function at compile time. So what it does, it uses one single method and causes and uses it as funnel, so it can use as per the need. So true runtime overriding. Suppose there is one parent class animal and has a method sound. So the sound method can output mew and woof both because this base method is inherited from animal and is overridden in dog and cat, as we have already done this. When sound is called, Python ignores the base method and whatever sound method does here, that sound will be done as per the object. Now context aware operators. So context is integers. In addition, it will add in strings, it will concatenate, and in lists it will merge. So yeah, operator overloading allows the same exact symbol to route entirely different C-level execution paths depending on different data types. Now, polymorphism in built-in functions. So the len function, uh, suppose there is geeks, will output 5. Being different data type, list will output 3 because it has length 3. In max, it will give out numbers maximum is 50 and zebra as maximum because z has the maximum ASCII value. So this is how in a polymorphism in built-in function works. So how it is it even showing polymorphism? The len function is taking input as in taking input of different data types. Sometimes it's taking string, sometimes taking lists, sometimes taking tuples. But it's giving correct answer in every single uh, uh, use because it's using polymorphism. It's using single name, but having different function for different data types. Same with the max function, min functions. Now, what is duck typing? Behavior over identity. If it walks like a duck and quacks like a duck. Polymorphism in Python does not require strict class hierarchies. Functions simply require objects to support specific behaviors, enabling massive code reusability. So this is stating that it doesn't mean that if it's saying if it walks like a duck and quacks like a duck and quacks like a duck. So it's behavior over identity. So it's using behavior over identity. So use of eraser and use of pen is different, and but it's performing a single task using a single method called dot use. Now this is resolution time, type checking, and flexibility between three languages, three types. So compile time is Java or C++, runtime overriding is Python, and depth typing is Python. Now in Java or C++, during the compile time, pre-execution gives the resolution time, and in Python it gives during execution, mid-execution. Now type checking is pretty strict in Java and C++, and Python, it's dynamic. It uses built-in libraries to check the data type. Now, flexibility is pretty low because obviously it's strict languages, and flexibility is medium in runtime overriding. In duck typing, it's the highest. Now, implementation mechanism, method overloading, and as I already told, method overloading is not present in Python, so it's method overriding, and in duck typing, it's shared method signature. So the Pythonic architecture in Python, polymorphism isn't just a OOP feature, you opt into it. It is the fundamental architectural philosophy of the language. Because of the dynamic typing, everything in Python is inherently polymorphic. From operators to built-in functions, the language constantly prioritizes flexible behavior over rigid identity, embrace the shapeshifter. So what it's saying that Python is very flexible, as I told you in the first lecture itself. Python is very flexible language. Why? Now you are getting to know it because of polymorphism. So polymorphism is implemented in every part of this Python to make it easier to learn language, and it's pretty flexible. In every built-in function, in polymorphism is depicted, and dynamic typing means the memory is getting allocated as per your type. As per your type, there is no need to declare data type. As in Python, you can just write a equals to 1, but in other languages like C, C++, Java, you have to initialize that it's an integer, then integer name, that you have to type any kind of integer. And if you then types any kind of string into it, it will give error because it's already integer. Then you have to first typecast it into a string, then write it in a string. But in Python, like what you can do is a equals to 1, a equals to string. There is no need to change it into any other data type. So this is how it's done. So that is the end for this polymorphism. Now there is another topic called abstraction. Abstraction is most easy to learn and most hard to learn at the same time because sometimes people get confused in it. So I'll just do it in a separate lecture itself. After that, we'll be doing Python self operator. We'll just deep diving into self operator. How does the self operator work? Then we will be implementing all the codes that we have, all the inheritance, abstraction, all the four pillars we have learned. Then we'll be implementing them into codes, and after that, we'll be maybe doing exception handling. We'll be just taking an overview over the exception handling and very possibly file handling too. So that is all for this lecture. So we are coming almost to the end of this Python series, and we'll most possibly end it in coming uh, one lecture. The next lecture might possibly be the last lecture because there is nothing much left to teach now. Other things I can say that you can start learning libraries from now on. I'll just tell you on how to import libraries. So suppose you want to import, I haven't taught this yet, so I'll just say, I'll just teach you. So you just have to write import math. We have imported now math libraries. In the same way, you can import anything. So suppose you want to import pandas, you will say import pandas as PD. So this is how you import different libraries. And how to install it, you have to just open command prompt and you have to just write pip install, then library name. Just say I want to install pandas. Uh, See, it's causing an error. Pip install matplot library. Okay, so it's giving some kind of error. It shouldn't give this error. I guess pip is not properly installed in my PC. So I'll just give my tutorial in the next lecture on how to install different libraries. And by that you can easily confirm. I'll just review my libraries and just fix this error. And in the next class, first of all, I'll just teach you on how to import the libraries and how to use them. So that is all for today. Thank you.